subject is from is a motion history analysis. Motion history analysis is a technique used in human action analysis to capture and represent the temporal evolution of human motion. It involves tracking the movement of key points on the human body over time and creating a visual representation of the motion history. Motion history image. A motion history image is a representation of human actions over time. It captures the temporal information of actions, allowing for analysis and understanding of motion patterns. MHIs are commonly used in computer vision and action recognition tasks. Use cases. Human action analysis. MHI can be used to analyze human actions and gestures in video sequences. By extracting and analyzing the motion history, it is possible to recognize and classify different actions, such as walking, running, and waving. Surveillance and security. MHI can be utilized in surveillance systems to detect and track motion in real time. By comparing the current MHI with the reference MHI, it is possible to identify and alert for any abnormal or suspicious activities. Sports analysis. MHI can be applied in sports analysis to track and analyze the movements of athletes. By extracting the motion history, it is possible to analyze the performance, technique, and patterns of athletes in various sports. Human computer interaction. MHI can be used in human computer interaction systems such as gesture recognition or motion based interfaces. By analyzing the motion history, it is possible to interpret and respond to user gestures and movements. Differences between motion history analysis and shape orientation analysis. Motion history analysis is a technique used in human action analysis to capture and represent the temporal evolution of human motion. It involves tracking the movement of key points on the human body over time and creating a visual representation of the motion history. Shape orientation analysis is another method used in human action analysis to analyze the orientation of the human body during different actions. It focuses on extracting shape features from the human silhouette and analyzing the changes in shape orientation over time. Extraction. MHI, a visual representation of the motion history, capturing the temporal information of human actions. MEI, motion energy image, an image that represents the spatial distribution of motion energy, highlighting regions with high motion activity. Histogram of oriented gradients, a feature descriptor that captures the shape of and orientation information of human actions. Optical flow, a technique that estimates the motion of object that between consecutive frames, providing information about the direction and speed of motion. The shape orientation image is a visual representation that captures the spatial information of the objects in a scene. It provides valuable insights into the shape and orientation of the objects, which can be used for various applications in human action analysis. SOI is created by analyzing the motion history of the objects in a video sequence. By tracking the movement of the objects over time, the SOI can be generated to depict the spatial distribution of the objects and their orientations. Use cases. HAR, Human Action Recognition. SOI can be used to recognize and classify different human actions based on the shape and orientation of the objects involved. For example, it can be used to identify specific gestures or movements in sign language recognition. Object tracking. SOI can assist in object tracking tasks by providing additional information about the shape and orientation of the tracked objects. This can improve the accuracy and robustness of object tracking algorithms. Scene understanding. SOI can contribute to scene understanding tasks by providing a visual representation of the object's spatial layout and orientation. This can be useful in applications such as surveillance, where detecting abnormal object orientations can indicate potential threats. Human action recognition is a field of computer vision that aims to identify and classify human actions from video sequences. Two commonly used techniques for the human action recognition are motion history and shape orientation based analysis. Motion history is a technique that captures the temporal evolution of motion information in a video. It involves extracting motion features from consecutive frames and representing them as a motion history image, MHI. The MHA provides a visual representation of the motion patterns in the video, which can be used for action recognition. Shape orientation is a technique that focuses on the spatial arrangement of human body parts during an action. It involves extracting shape features from key body points or key points and representing them as a shape orientation histogram. The histogram captures the distribution of shape orientations, which can be used to classify different actions. Algorithms. Several algorithms have been developed for human action recognition using motion history and shape-oriented based analysis. Some popular orientation algorithms include hidden marker models, support vector machines, CNNs. These algorithms leverage the motion and shape information extracted from videos to learn action patterns and classify new actions. So here are the experimental results. Conclusion. The motion history and shape orientation based human action analysis has provided valuable insights into understanding human behavior and actions. The key findings from the analysis are accurate action recognition. The motion history and shape orientation techniques have proven to be effective in accurately recognizing and classifying different human actions. Robustness to variations. The analysis has shown robustness to variations in lighting conditions, cameras, viewpoints, and occlusions. Potential applications. The findings from the analysis can be applied in various domains such as surveillance, video games, and human computer interaction. Future directions for research in this area include incorporating deep learning, integrating deep learning techniques can further enhance the accuracy and performance of the analysis. Real-time action recognition. Developing real-time action recognition systems that can analyze and classify actions in real time. Multimodal analysis. Exploring the use of multimodal data, such as combining video and audio data, to improve the accuracy of action recognition. Thank you.